Hello everybody, I want to take a minute and talk to you about energy stored in a capacitor. So we know that a capacitor is effectively a separation of charge, so that means there must be some energy associated with it because it would be stored energy due to configuration, so it's got to be a potential energy. So if we remember from our definition of voltage, I have some delta V here. So the potential energy would be equal to Q delta V. I also know that Q is equal to CV when I'm talking about a capacitor. And this is a little bit difficult to understand sometimes because we use lowercase q and uppercase q interchangeably a little bit, but there is a subtle difference. Uppercase q usually means total charge, and lowercase q oftentimes means the test charge or some small dq. So if I want to look at this from the perspective of calculus, this is pretty straightforward. I actually then have that du is equal to q dv, and then I can just use this relationship that says q or v is equal to q over c. And then I get something that looks like du equals 1 over c q dq, and c is a constant, so I don't have to worry about the differential of c. I integrate both sides, and I get that u is equal to q squared over 2c, which I could also write as 1/2 cv squared. Another way to think about this would be to think about the average potential and to think about U being equal to Q V average. And in that case, the average velocity, or not velocity, potential, if I think about the potential as a function of Q, would give us this triangular relationship. So I would say that I now have Q and V, and I have a linear relationship. So V average is just 1/2 V, so I get Q times 1/2 V. And through all of my various substitutions, I can come up with Q equals CV. I could then write U as 1/2 QV, or 1/2 CV squared, or 1 over 2C Q squared. So that's a little bit about energy stored in a capacitor. I could also talk about the potential energy density, which I may do in another video.